one of the second order special case. Like what I illustrated a while ago, what you're going to do is to let u be equal to the expression inside the parenthesis. And so this whole expression here, would now be the derivative of u, because you have let this expression here be equal to u. So the derivative of u with respect to x equals negative 2x to the negative 3. And then here comes integration. Because this is exclusively u and this is exclusively x. So the answer in the left side is u, and in the right side, you're going to integrate x to the negative 3. What's the integral of x to the negative 3? You have x to the negative 3 plus 1 over negative 3 plus 1 plus c sub 1. We will write c sub 1 because we are going to integrate twice this time, because we have second order. So when you say second order, you're going to integrate twice. And so simplifying our u, we now have, this is negative 2. And so this will cancel out. And what's left now is x to the negative 2 plus c sub 1. We're going to equate 1 and 2. So we have x dy over dx plus 2y equals x to the negative 2 plus c sub 1. And obviously, you can manipulate this so that this will be transformed to folde by multiplying both sides by 1 over x, so that the x here will disappear or eliminated. So the next slide should be plus, or we can write y first, and then 2 over x. Isolating this, meaning you have identified your p of x as equal to 2 over x. Okay, class? So you can have a denominator of x. Tapos on the right side, we have x to the negative 2 over x plus c sub 1. But this x to the negative 2 over x, you can also write it as 1 over x cubed. Okay? So now, your p of x is 2 over x. And your q of x in folde is 1 over x cubed plus c sub 1. And proceeding to solve for the integrating factor, we have dx over x, because this one is the component of your integrating factor. If you still remember how to solve using folde squared. And so the next step is to write y integrating factor equals the integral of the integrating factor times the q of x dx plus c sub 2. Okay, so we have this c sub 2, it arises from the integral or the integration of this expression here. So we substitute the value, which is our integrating factor, x squared, and then the plus c sub 1. Then we have here plus c sub 2. So there's no need to include c sub 2 in the integration, because that is actually the derivative or the part of the process of integrating the second time. And so we have here y times x squared, and then we will integrate this one. But first, we have to simplify by distributing x squared to both terms inside the parentheses. And so We can distribute the integral sign. What's left here, we have here a dx, by the way. So we have dx over x, because we still have 1 over x in the first term, plus the integral. When you distribute x squared, so you have x squared dx, and the c sub 1 is a constant. It should be written outside of the integral sign, plus c sub 2. So arranging this, so you have ln of x plus c sub 1. By the way, this is x squared. Why did I write x sub 2? So you have x cubed over 3, and then plus c sub 2. Okay? And finally, our answer should be, this is the final answer. Okay, our final answer is this one. Equals 6x plus 3. So again, you let u be equal to dy dx. And so this is now written as integrate both sides. Okay. And so you have u is equal to 6x squared over 2 plus 3x plus c sub 1. This is your equation 2. So it's the same process, class. Du dx equated to 6. This is already 3. 3x squared plus 3x plus c sub 1. So this is quite simple. You don't need to go through all day in this case. I'm sorry. This is dy dx over, so you have dy, and then you have 3x squared plus 3x plus c sub 1 quantity dx. So this is simpler than the first one, because there's no need for you to go through full day. This is just simple integration, variable separable. So the answer, second integration, I think we can write it here in the other side. So you have y equals 3x cubed over 3 plus 3x squared over 2 plus x c sub 1 plus c sub 2. Okay. Simplifying, y equals x cubed plus 3 over 2 x squared plus c sub 1x plus c sub 2. Okay. The case 2, because you don't have a y variable. These are derivatives. So if you write it, it will be dy, or the second derivative of y with respect to x, plus 2x dy dx equals 1. There is no y variable. So when you see that the given differential equation has no y variable, it belongs to case 2. So what are we going to do? Our substitution says we let p be equal to dy dx. And the derivative of p with respect to x is the second derivative of y with respect to x. So we will use this to substitute our equation here. So it will now be in terms of p and x. So you have x squared, and this one be written as dp dx, and then plus 2x. This one here will be written as p equals 1. Now this is obviously in full day form, wherein we can eliminate this x squared here by multiplying both sides by 1 over x squared, so that the next line only contains dp dx, plus you have a p as a dependent variable, and then you isolate 2x now divided by x squared equals 1 over x squared. So you can now identify that your p of x is actually equal to 2 over x. Okay, class? Because this is 2 over x. What's left here is 2 over x. And your q of x equals 1 over x squared. All right? Given that our integrating factor is x squared, the next line should be p, which is our dependent variable right here. It's our dependent variable instead of y. Integrating factor equals the integral of integrating factor times the q of x dx and then plus c sub 1. But what is our integrating factor? You have x squared. And then you have x squared times the q of x, which is 1 over x squared, then dx plus c sub 1. So this will cancel out, and we still have p here. X squared equals, the integral of dx is simply x plus c sub 1. Now, what is your p? Your p is equal to dy dx. So this is substituting our p, dy dx, times x squared equals x plus c sub 1. Okay. Now, this is not folde. Why? Because our dependent variable is y. And even if we arrange this, we cannot proceed, or we cannot transform this class into dy dx plus y p of x equals q of x. We cannot transform it this way because we don't have this y variable among the terms. It doesn't have a y variable. But this can be solved by variable separable. You don't need to go through. So, in case 2, you don't know kung ano yung result after solving for, after integrating, no? After this line here, you cannot predict kung ano yung next na magiging step mo. It's not always folde. It could be, as you can see in this case, that is simply variable separable. So we can group together, say I'm going to multiply both sides by dx over x squared. So if I multiply dx over x squared, what's left in the left side is dy. Okay, dy. And this is multiplied by x plus, yung x plus c sub 1 is now divided by x squared and then multiplied by dx. Okay. And so, denominator, this should be x to the negative 1. We can write it this way. Tapos may dx tayo dyan. Plus c sub 1 over x squared. Tapos may dx tayo dyan. Because we can distribute the dx, no? And also the denominator. Sundan niyo ako, class? Ha? Sundan niyo ako?
Opo.
Yes. Okay, continue tayo. This is simply ln of x. We will integrate both sides. So integrate in the second page or in the next page. Bakit ko ba kailangang i-rotate to? Pwede naman akong same template sana. Okay, so integrating both sides, we now have the integral of dy equals the integral of dx over x plus the integral of, labas natin si c1, and then we have dx over x squared. Right? Okay. And then plus c sub 2 because you integrate the second time. Integral of dy is y. Integral of this is ln of x. And then you have c sub 1. The integral of x to the negative 2 is x to the negative 2 plus 1 over negative 2 plus 1 plus c sub 2. So final answer, almost there. This is already negative because we have a negative 1 as a denominator. So c sub 1, and this is x to the negative 1. Okay, plus c sub 2. Finally, our answer, simplifying, or pwede na to, no? Yeah, this is our final answer. So when x is missing, what are we going to do? Okay, let's have an example here. Let's say 2y, y double prime plus y squared equals y prime squared. As you can see, you don't have an x variable. You don't have an x variable. So you can write this as 2y, second derivative of y with respect to x, plus y squared equals dy dx, quantity squared. Okay, so our substitution here is you let your p still be equal to dy dx. However, your y double prime, which is the second derivative of y with respect to x, you cannot use this expression, that you cannot equate your p to the second derivative of y with respect to x. No, because you don't have an x variable. So, paano ka makapag-integrate kung wala ka namang x variable? So, using chain rule, your p should be equated to, by the way, yung dp. Mali tayo dito. Ulitin ko, class, ha? Mali tayo dyan. You cannot equate yung, you cannot simply say na yung second derivative of y with respect to x is equal to dp dx. No, you cannot do that kasi you don't have an x variable. So you cannot use this. Unlike the first, when the y variable is missing, we equated the second derivative of y with respect to x to dp dx. But this time, since we don't have an x variable, we cannot use this one. We cannot use that. So we're going to express our second derivative of y with respect to x as equal to p dp dy. P dp dx, you cannot do that. So we will equate it with, okay, let me check dun sa ano natin, ha. Sa given, kung tama ba tong substitution natin sa case 2, the third type. Yeah, tama, class. So we can now use this instead of using this one, yung sa y is missing, we use this one in the substitution. So therefore, this line here will be replaced by y and p. So you have 2y, and the second derivative of y with respect to x will be written as p dp dy, and then plus y squared equals p squared. That is now our new differential equation in terms of p and y. Okay. And what do you think? What do you think would be the transformation?
Homogeneous DE po.
Homogeneous? Homogeneous? Okay, let us see. Why do you say it's a homogeneous differential equation?
Kasi po ma'am may second degree, ay may degree 2 po siya, tapos pwede na po tayong mag-let P equals VY po. Let na po. Tapos reduce ulit.
Mm. Meaning to say we have to write it first in terms of, yeah, we can use homogeneous. Pero nahahabaan ako sa homogeneous na approach class. Pwede rin na mag-folde ka dito. Or Bernoulli kaya. Yeah. Pwedeng homogeneous, yes, because this is actually a homogeneous differential equation. So you can use homogeneous differential equation approach, but you can also use Bernoulli. I think I can use Bernoulli. So I'm going to use Bernoulli class for you to have also a choice, no? Let's say if I'm going to divide this by 1 over 2yp, so this will be eliminated, and I have dp dy here. And the second term will be multiplied. Our p is our dependent variable. Let me check. So this is y squared over, but there's no p in the second term. So definitely that's your q of y. That's your q of y. It should be transposed to the other side next time, the next line. So this is 2yp equals, you have p squared over 2yp. Simplifying that, okay, let's go to the next. We will simplify this one. So you have dy d dp dy plus dp dy plus, we can factor. We don't have a p variable. Yeah, we have one pero nasa baba. So in the template for the Bernoulli, the dependent variable should be nasa taas. But looking at the second, or in the right side, we have a p nasa taas because this can be reduced to p over 2y. So this will be the second term in the template of Bernoulli, such that we will write negative because we will transpose this to the other side, so it becomes negative. So I have here negative p over 2y. Okay, negative p over 2y, and this one will be transposed to the other side, now reduced to y over 2p equals negative y over 2p. Okay, and so I'm going to rewrite this minus, pwede rin, I can use this, the addition. So plus, and then the dependent variable p, and then I have my q of p. So that is 1 over 2y. Equated to, I have my p to the negative 1, wherein this is my n. And then I have y over 2 as my q of y, right? So my p of y is negative 1 over 2y, and my q of y is actually y over 2. And my n, as I have written above, is negative 1. So I'm going to use Bernoulli. To transform this, we have to find PR of y, which is 1 minus n. But what is our n? Negative 1. So this becomes positive now. And then we have negative 1 over 2y. So simplifying, we have negative. So this will cancel out. This is 2, and we have a 2 here. So what do we have? Negative 1 over y. It's our PR of x, negative 1 over y. And our QR of y, I'm sorry, it's not x, it's y. We still have 1 plus 1, and our q of y is y over 2. So, still, mag-cancel din yan, and we have y. Okay, we can now proceed to solving for our integrating factor, e to the integral of we have negative dy over y. Okay, so this is e to the negative ln of y, or that is simply equal to e to the ln of y to the negative 1, or 1 over y. That's our integrating factor. And so our next line is our dependent variable, remember, is p. It's our dependent variable. So p times the integrating factor is equal to the integral of the integrating factor times the QR of y dy, and then plus c sub 1. Right? And so the next line should be p over y equated to our q of y is y. This one. And our integrating factor is 1 over y. So this will cancel out. We have y times 1 over y dy plus c sub 1. So I find Bernoulli easier and shorter rather than solving for homogeneous. So we have y, because this will cancel, and then plus c sub 1. Okay. And so if I'm going to replace the p, I know that my p is dy dx. So here comes the dy dx variable na. No? So I have used this one. So I'm going to replace my p as dy dx. So dy dx times 1 over y equals y plus c sub 1. Okay. Y over y. And this is y plus c sub 1. I'm going to transfer the dx. So I'm going to multiply dx in the first line so that it will now be cancelled with respect to the left side of the equation, and what's left is dy over y. But in the right side, we have a dx. But this is in terms of y. So what am I going to do? I'm going to move this to the other side. So I have dy over y plus c sub 1 equals dx. Integrating both sides. Kaya lang, paano mo i-integrate ito? Anong integral ng dy over y and then y plus c sub 1? You can use partial fractions. Still remember partial fractions? Coefficients are the factors of the denominator are prime, linear, non-repeating. So we can write this, kasi itong nasa right side, ang integral nito is just simply x plus c sub 2. Okay? But the left side, yun ang problema natin. So let's say 1 over y y plus c sub 1, that could be any constant. We can write it as a over y plus b over y plus c sub 1. Both sides by y times y plus c sub 1, what's left in the left side is 1. And so we have a times y plus c sub 1 plus b times y. And we let y equals 0, so we can solve for a. So a times 0 plus c sub 1. So we have um, a times c sub 1, or a is actually equal to 1 over c sub 1. Okay. Now, solving for b, we let y be equal to negative c sub 1. So we have 1 equals a times 0 na to plus b times negative c sub 1. For y, negative ito, no? So, meron tayo dito b, negative b times c sub 1. Or meaning your b is actually negative 1 over c sub 1. Okay, so, so, itong expression na to, ito yun, initially, no? Yan siya, plus. So, isinulat natin siya as, dy over y plus c sub 1 as equal to, ano nga ba yung a natin? 1 over c sub 1. 1 over c sub 1 integral of the dy over y. Okay. dy over y. Minus na to. So, we have 1 over c sub 1 ln of y minus 1 over c sub 1. What's the integral of y over? So, let's say w be equal to y plus c sub 1. Derivative of your w is dy. So, this is dw over w. And so, that is actually ln. No? 1 over c sub 1. And we can also write this as 1 over c sub 1 ln. Minus yan, class. So, it could be written as y over y plus c sub 1. Plus c sub 2. Meron tayo ditong plus c sub 2. Tapos sa kabila, meron tayong sagot na x. X na lang kasi may c sub 2 na pala. Actually, pwede rin wala na rin ito. Pwede natin itong i-equate dun sa sagot natin na x plus c sub 2. So, meaning x plus c sub 2. Okay. Which is different from the answer sa book. Pero at least may sagot ako. Hindi ako So, ipa-factor mo yung 1 over c sub 1 dyan. Meron tayong ln of y minus ln of y plus c sub 1. Okay. Tapos, tanggalin natin yung c sub 2 dyan. Kasi doon na yun sa ano. Tapos, this is equated to x plus c sub 2. O, yan. So, pwede rin. Okay. 1 over c sub 1. And this is ln of y over y plus c sub 1 equals x plus c sub 2. Kung i-simplify natin yan, wala na siya eh. I have a different solution. I don't know if this solution is the same as that one nandun sa libro. Pero, checking my solution, wala naman tayong na-violate na error dito. Ginamitan natin siya ng partial fraction. And then, yung right side naman is simply x plus c sub 2. At wala naman tayong na-violate sa pag-substitute natin ng mga values para ma-solve yung arbitrary constant a and b, which is a is 1 over c sub 1. And then yung b naman natin is negative 1 over c sub 1. Okay. I think this is it.